Good day everyone, I am Klyonne Campos and I'll discussing about sequences and series. So objectives. At the end of the lesson, the students will be able to first to determine the different types of sequences and series. Next is to solve the different types of sequences and series and apply the different types of sequences and series in real life situation. So, sequence. A sequence or a progression is a set of numbers written in succession. So, each number of sequence is called term. So, the first number is called the first term, followed by the second term and third term, and so on. So, example. This is example of sequence. So, these are the terms 1, 4, 9, 16, and 25. So, the first one is the first term, second term, third term, fourth term, fifth term, and so on. So, this group of number has a sequence which has the rule of squaring counting numbers from 1 to 5. For example, so square means 1 raised to the power of 2. So 1 times 1 is equal to 1. So 2 times 2 is equal to 4. 3 times 3 is equal to 9. 4 times 4 is equal to 16, and 5 times 5 is equal to 25. So, next example. So, this example is a infinite sequence. So, every term after the first is obtained by adding 2 to the number preceding it. So, adding 2. So, 2 plus 2 is equal to 4. So, 4 plus 2 is equal to 6, and 6 plus 2 is equal to 8, and 8 plus 2 is equal to 10, and so on. So, a sequence may be finite and infinite depending on its term. So, finite sequence example. So, finite sequence, it has a first term and a last term. So, for example, so 1, 3, 5, 7, 9, and 11. So it has a first term which is 1 and a last term which is 11. So the first term is 1 and the last term is 11. So the next example, so it has also first term and last term, which the first term is 2 and the last term is 14. So, this is also the example on infinite sequence. So, infinite sequence, it has the first term, but it doesn't have a last term, which is infinity or so on. Like in this example, it has first term, which is 3, and the last term is 3, and which n is a positive counting number, which n can substitute any number or infinity. So, in this example also, it has first term which is 2, and the last term n, the quantity of n plus 1, where n is a positive counting number, which n can substitute any number. So, it means it is infinity, which this example are infinite sequence which has no last term. So subscripts used to designate the ordinal of a term, it is a customary to use a sub 1, a sub 2, a sub 3, and so on. A sub n to designate a sequence of n terms, which a sub n or the subscript n is understood that from 1 to 4. So like this example has 1, 2, 3. These are the subscripts or the A sub n. So example, write the 4 terms of the sequence A sub n is equal to n plus 1. So, which is the subscripts will be 1, 2, 3, and 4 because we're finding the first 4 terms. So, solution. Substitute the natural numbers from 1 to 4 for n one after another. So, we will just substitute n into 1, which is finding the first term, second term, third term, and fourth term. So, formula A sub n is equal to n plus 1. So, it becomes A sub 1 is equal to 1 plus 1 is equal to 2. Then, in A sub 2 is equal to 2 plus 1 is equal to 3. Then, in A sub 3 is equal to 3 plus 1 is equal to 4. And A sub 4 is equal to 4 plus 1 is equal to 5. So, A sub 1 will be the first term, A sub 2 is the second term, A sub 3 is the third term, and A sub 4 is the fourth term. So, the first 4 terms of the sequence are 2, 3, 4, 5, which is based on the substitution and the formula. The A sub 1 will be 2, and the A sub 2 is equal to 3, and A sub 3 is equal to 4, and A sub 4 is equal to 5. So, next example. What is the 10th term of sequence A sub n is equal to n plus 1? So, solution. So, A sub n is equal to n plus 1, which n is equal to the 10th term. So, A sub 10 is equal to 10, n is equal to 10, so plus 1, so is equal to 11. 10 plus 1 is equal to 11. So, now let's proceed to deriving the rule for generating a sequence. So, since a sequence is an ordered collection of natural numbers, it can sometimes be described by an equation. The first few terms are given from which the general term is defined. So, for example, so sequence which is 4, 5, 6, 7, and so on. So, how we generate this into equation? So, in finding the formula of the first term or second term, we use the A sub n is equal to n plus 1. So, in this example, so we still use the A sub n is equal. So, but first, we will just find out what number we will add to n in order to get the first term. So, let's try the 2. So, what if this would be 2? So, 2 plus 1 is equal to 3. Therefore, it is not the formula because in this example, the first term is 4. So, let's try 3. So, A sub 1 is equal to 3. So, 3 plus 1 is equal to 4. So, as you see, the first term is 4. Therefore, we will now use 3 to add the n. So, for example, A sub 1 is equal to 3 plus 1 is equal to 4. So, A sub 2. So, A sub 2 is equal to 3 plus 2 is equal to 5. So, it's also 5 the second term. So, next, A sub 3 is equal to 3 plus 3 is equal to 6. So, the third term is equal to 6, and A sub 4 is equal to 3 plus 4 is equal to 7. So, the fourth term is 7 and so on. So, now, our equation will be A sub n is equal to 3 plus n or n plus 3. So, now, let's proceed to arithmetic sequence. So, arithmetic sequence is a sequence in which each term after the first is obtained by adding up constant d to the preceding term. So the constant number d is called the common difference. So let's know how to get the common difference of a sequence. So example, 1, 3, 5, 7. So in order to find the common difference of this sequence, let the second term minus by the first term. For example, the second term will be 3 and the first term will be 1. So 3 minus 1 is equal to 2. So therefore, the common difference is equal to 2. We will now use the third term subtracted by the second term. So 5 minus 3 is also 2. So as well as 7 minus 5 is equal to 2. Therefore, the common difference is equal to 2. In order to check that the common difference are 2, we will just add the first term in order to get the second term. Like for example, 1 plus 2 is equal to 3, 3 plus 2 is equal to 5, and 5 plus 2 is equal to 7, and so on. So now let's proceed to the next example. So negative 3, negative 6, negative 9, negative 12, and so on. So negative 6 minus negative 3 is equal to negative 3. So negative 9 minus negative 6 is equal to negative 3. So negative 12 minus negative 9 is equal to negative 3. Therefore, the common difference of this arithmetic sequence is negative 3. So let's check. So negative 3 plus negative 3 is equal to negative 6. And negative 6 plus negative 3 is equal to negative 9. And negative 9 plus negative 3 is equal to negative 12. So next is the nth term of an arithmetic sequence is defined as a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, which is the common difference, where a sub 1 is the first term and a sub n is the nth term, and the d is the common difference. So for example, the fourth term of an arithmetic sequence is 18 and the sixth term is 28. We cannot just 28 minus 18 because the fifth term is missing. We cannot get the common difference, so we will use a formula which is in here in order to find the common difference as well as the first three terms. So given a sub 4 is equal to 18 and the a sub 6 is equal to 28. So example, find the a sub 3, a sub 2, and a sub 1, which is the third term, second term, and the first term. So solution. There are three terms from a sub 4 to a sub 6. So assume that a sub 4 as a sub 1 and a sub 6 as a sub 3 to find the common difference. So a sub 3 is equal to a sub 1 plus the quantity of 3 minus 1 times the common difference. So 28 is equal to 18 plus 2 times the common difference. So it becomes 2d is equal to, so 28 minus 18 is equal to 10. So 10 divided by 2 is equal to 5. Therefore, the common difference is 5. So using the common difference and the a sub 4 is equal to 18 we have. So we will know now how to find the third term, second term, and the first term. So in finding third term, so a sub 3 is equal to 18 minus 5 is equal to 13. So in a sub 2 is equal to 13 minus 5 is equal to 8. And the first term is equal to 8 minus 5 is equal to 3. So the first term will be 3, second term will be 8, and the third term will be 13 in the arithmetic sequence. So now let's find the common difference in the nth term of an arithmetic sequence. For example, find the 14th term of the arithmetic sequence. 5, 7, 9, 11, and so on. So, solution. So, a sub 1 will be 5, which is the first term. N is equal to 14, and the common difference is equal to 2. So, a sub n, the formula is equal to a sub 1 plus times n minus 1 times the common difference. So, a sub 14 is equal to 5 plus 14 minus 1 times 2, which is the common difference. So, is equal to 5 plus 13 times 2 is equal to 26. So, 5. So, 5 plus 26 is equal to 31. So, now let's move to arithmetic series. So, a series is the indicated sum of the terms of a sequence. So, formula for the sum of the first n terms is an arithmetic sequence. So, this would be the formula of finding the arithmetic series. So, S sub n is equal to n over 2 times 2 times a sub 1 plus the quantity of n minus 1 times the common difference. Where Sn is equal to sum, a sub 1 is the first term, d is the common difference, and a sub n is the nth term. So, example, find the sum of the first 10 terms of the arithmetic sequence. So, 4, 10, 16, and so on. So, solution, a sub 1 is equal to 4, n is equal to 10, d is equal to 6. So, formula. So, S sub n is equal to n over 2. So, times 2 times a sub 1 plus n minus 1 times the common difference. So, S sub 10 is equal to 10 over 2 times 2 times 4 plus 10 minus 1 times the common difference 6. So, 5. So, 2 times 4 is equal to 8. And 10 minus 1 is equal to 9, then times 6. So, 6 times 9 is equal to 54. So, 54 plus 8 is equal to 62. Then, 62 times 5 is equal to 310. Therefore, the first 10 terms of the arithmetic sequence is equal to 310. So, let's move to the real-life example. So, a house helper receives a salary of 36,000 pesos a year with a contract of 250 pesos annual increase for 7 years. What is his total income for 7 years? So, solution. A sub 1 is equal to 36,000 pesos. Then, the n is equal to 7 years. Then, the common difference is equal to 250 pesos. So, S sub n is equal to n over 2. So, times 2 times a sub 1 plus n minus 1 times d. So, S sub n is equal to 7 over 2 times 2 times 36,000 plus 7 minus 1 times 250. So, S sub 7 is equal to 7 over 2 times 236,000 plus 6 times 250. So, 7 over 2 is equal to 2 times 36,000 is equal to 72,000. Then, 6 times 250 is equal to 1,500. Then, 72,000 plus 1,500 is equal to 73,500. Then, 7 over 2 times 73,500 is equal to 250 57,250, which is the total salary of 7 years. So now let's move to arithmetic mean. So in a fancy term, which sometimes called average of two numbers, it simply involves taking the sum of a group of numbers, then dividing the sum by the count of the numbers used in the series. So this would be the formula of arithmetic mean. So a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, which is the common difference. So example, insert 3 arithmetic means between 3 and 23. So solution. So the a sub 1 or the first term is 3 and a sub 5 is equal to 23. Then n is equal to 5 and we will find the common difference. So formula, a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. So a sub n is equal to 23. So 23 is equal to 3, which is the first term, plus 5 minus 1 times d. So 23 is equal to 3 plus 4d. So 4d is equal to 20 because 23 minus 3 is equal to 20. So d is equal to 5 because 20 divided by 4 is equal to 5. Therefore, the common difference is 5. So, in order to know the between of 3 and 23, let's just add the common difference in the first term and so on. So, 3 plus 5 is equal to 8 and 8 plus 5 is equal to 13 and 13 plus 5 is equal to 18 and 18 plus 5 is equal to 23. So the three arithmetic means between 3 and 23 are 8, 13, and 18. So now let's move to geometric sequence. So geometric sequence is a sequence in which a term is obtained by multiplying the preceding term by a constant number called the common ratio or R. So, in arithmetic sequence, it is adding the first term by the common difference. And in order to get the common difference, we will subtract the second term into the first term and so on. While in geometric sequence, it has common ratio, which we will get if the second term divided by first term. So in order also to continue the sequence, just multiply the first term into the common ratio and so on. So example, 2, 4, 8, 16, 32, and 64. So, in order to know the common ratio of this geometric sequence, so the second term divided by the first term. So, the second term is 4 and the first term is 2. So, 4 divided by 2 is equal to 2. Therefore, the common ratio is equal to 2. So, 2 times 2 is equal to 4. 4 times 2 is equal to 8. 8 times 2 is equal to 16. 16 times 2 is equal to 32. 32 times 2 is equal to 64. So, how about this second example? So, the second term is 6. So, and the first term is 2. So, 6 divided by 2 is equal to 3. So, let's check. 3 times 2 is equal to 6. 6 times 3 is equal to 18. 18 times 3 is equal to 54 and 54 times 3 is equal to 162. So now let's find the nth term of a geometric sequence. So formula, a sub n is equal to a sub 1 times r raised to n minus 1. where a sub 1 is equal to first term and a sub n is equal to n term and r is the common ratio. So example, find the 10th term of the geometric sequence 2, 4, 8, and so on. So solution, a sub 1 is equal to 2 and the r is equal to 2 and n is equal to 10. So formula, a sub n is equal to a sub 1 times r raised to n minus 1. So a sub 10 is equal to 2 times 2 raised to the power of 10 minus 1. So 2 times 2 raised to 9. So 2 raised to 9 is equal to 512 times 2 is equal to 1024, which is the 10th term of the geometric sequence 2, 4, and 8. So now let's proceed to infinite geometric series. So formula, S sub n is equal to a sub 1 minus a sub 1 times r raised to n all over 1 minus 3, where S sub n is the sum and a sub 1 is the first term and r is the common ratio. So example, find the sum of a sub 1 is equal to 40, n is equal to 6, and r is equal to negative 1/2. So the formula, which is S sub n is equal to a sub 1 minus a sub 1 times r raised to n all over 1 minus r. So S sub n is equal to 40 minus 40 times negative 1/2 raised to n all over 1 minus negative 1/2. So is equal to 39 and 3/8 all over 3 over 2 is equal to 315 over 12 is equal to 26 and 1/4. So now let's move in infinite geometric series. So formula, S is equal to a sub 1 over 1 minus r. So example, find the sum of 3 over 10 plus 3 over 100 plus 3 over 1000 and so on. So solution, a sub 1 is equal to 3 over 10. So the common ratio is equal to 1 over 10 because if 3 over 100 divided by 3 over 10 is equal to 1 over 10. So S is equal to a sub 1 over 1 minus 3 is equal to 3 over 10 all over 1 minus 3 over 10 is equal to 3 over 10 and 9 over 10, but we reciprocal to cancel out, so it becomes 10 over 9. Then cancel 3, it becomes 1 and it becomes 3, and 10 and 10 will be 1, so 1 times 1 is equal to 1 and 1 times 3 is equal to 3. So now let's proceed to the example of real life problem of the infinite geometric series. So the decimal 0.999 and so on is called a repeating decimal. So show that this is equal to 1. So first we write it into a fraction. So 0.999 is equal to 9 over 10 plus 9 over 100 plus 9 over 1000 and so on. So solution, a sub 1 is equal to 9 over 10 and the ratio is equal to 1 over 10 because 9 over 100 divided by 1 over 10 is equal to 1 over 10. So S is equal to a sub 1 over 1 minus 3 is equal to 9 over 10 all over 1 minus 1 over 10 is equal to 9 over 10 all over 9 over 10 is equal to 9 over 10 and 9 over 10. So as we reciprocal to cancel out, so it becomes 10 over 9. So, cancel out 9 into 1, then 10 also into 1. Therefore, 1 times 1 is 1, and 1 times 1 is 1. Therefore, 1 divided by 1 is equal to 1. So, now let's proceed to geometric mean. So, is the average value or mean, which signifies the central tendency of the set of numbers by finding the product of their values. So, example, find the geometric mean between 3 and 12. Solution, 3 over m is equal to m over 12. So, just multiply. So, m times m is equal to m squared, then 3 times 12 is equal to 36. Then square root, it becomes m is equal to plus minus 6, which is the square root of 36 is equal to 6. So example, insert two geometric means between 3 and 192. So in this example, we're finding two geometric means, therefore, this will be the formula of finding the two geometric means between 3 and 192. So, solution, a sub 1 is equal to 3, and the n is equal to 4, and a sub 4 is equal to 192. So, formula, a sub 4 is equal to a sub 1 times r raised to n minus 1. So, 192 is equal to 3 times r raised to the power of 4 minus 1. So, r squared, so 3 divided by 192 is equal to 64. R squared is equal to 4 squared, because 4 times 4 times 4 is equal to 64. Then r is equal to 4. So, the geometric means is equal to 3, 12, 48, and 192. So, the missing two geometric means are 12 and 48. So, you can test yourself. In order, you will know if you have learned from my discussion. Okay, thank you so much for listening from my discussion.